topic for today's presentation is data mining. My name is Venkatesh. Here goes my first slide. It talks about Euclidean distance. Euclidean distance is nothing but distance between 2 points in space. Here the distance can be calculated with the help of Pythagoras theorem. Here the distance obeys all the defining properties of a metric space. The following are the properties of Euclidean distance. The first one is symmetric, the next one is positive, and the third one is triangle inequality. A distance that satisfies this properties is called metric. Coming to my next slide, it talks about common properties of similarity. The first one is S of P comma Q equal to 1 only if P equal to Q. The next one is S of P comma Q equal to S of Q comma P for all P and Q symmetry, where S of P comma Q is the similarity between the points P and Q. Coming to my next slide, talks about binary vectors and its similarities. Statistics for analyzing the similarity and variety of sample sets is called SMC. Here, SMC is nothing but a simple matching coefficient. It is also known as a random similarity coefficient. SMC is defined as number of matches divided by number of attributes. Here goes its formula. And the Jacobi coefficient is defined as number of 11 matches divided by number of not both zero attributes. Here goes its formula. We can compute the similarities using the following quantities. For example, let's take M01, where number of attributes where P was 0 and Q was 1 and so on. Coming to my next slide, it talks about difference between SMC and Jacobi coefficient. The SMC resembles the more well-known Jacobi index. The SMC has the phrase M00 in its numerator as well as in its denominator, but Jacobi index doesn't have it. As a result, SMC counts both mutual presence as well as mutual absence as matches and compares them to the total number of attributes in the universe, whereas Jacobi index only counts mutual presence as matches and compares them to the number of attributes chosen by at least one of the two sets. For example, let's take like P as 100000 and Q as 0001001. From above P and Q, we get M01 equal to 2, M10 equal to 1, M00 equal to 7, and M11 equal to 0. By substituting these values in SMC formula, we get the result as 0.7, and in Jacobi coefficient, we get the result as 0. Coming to the next slide, it talks about cosine similarity, which is defined as dot product of vectors divided by product of their length in inner product space. For example, if d1, d2 are two vectors, then the cosine of d1 comma d2 equal to d1 dot product d2 divided by d1 into d2. For example, let's take d1 equal to 32050002000 and d2 as 10000102. d1 dot product d2 gives us the value 5 and d1 gives us a value 6.481 and d2 gives us a value 2.245. At the end, cosine of d1 comma d2 gives us a value 0.3150. Here goes my question. What is the difference between SMC formula and Jacobi coefficient? And the answer is SMC has M00 in its numerator as well as in its denominator, whereas Jacobi coefficient doesn't have it. Thank you guys.